All right. Let's start cranking through it. So number one, calculator, tangent of x equals 2. Use a calculator to find all the answers. So, hey, did you all get that email I sent you, when was it? Monday? Yeah, Monday after class, or I mean a few hours that afternoon. So I finished up the rest of the lecture on, which is like number one here. So I hope you got that. I sent whatever email you put into Math Excel. That's the one I sent it to, that had the rest of the YouTube lecture that I kind of ran out of time on in class. Okay, so this is a calculator. How do you do the calculator ones? So I wrote some instructions for you in that YouTube lecture I sent you. And it said, how do I classify this? So a lot of this is recognition, right? Recognizing. How do I recognize this? Well, this is, I need to use my calculator to solve, because tangent x equals 2.0, that's not one of our memorized values, is it? That's not small, medium, or large. That's not root 3 over 2, or root 2 over 2, or a half, or something, or 1, or 0, or negative 1. That's not one of our memorized values, is it? So when you use the calculator, I said step number 1, change to positive. Did y'all see that? Now, it already is positive, so great, don't need to do anything with it. But if that was negative 2, I would change it to positive because I want to get the first quadrant answer. All right, so it's already positive. Then you just hit the inverse tangent button on your calculator, inverse tangent at 2.0. Make sure you're in radian mode. Use calculator, inverse tangent, radian mode. You've got to make sure your calculator's in radian mode or nothing good's going to happen. I'm in radian mode. Okay, so I'm going to go tan inverse on your calculator. Tan inverse of 2. I'm getting 1.107. So you can round that 1.11. So they all have 1.11. That's not very helpful, is it? They all have that. So I need the second answer. How do I get the second answer? Yeah, first off, find the other quadrant. Now, what do you mean the other quadrant? Well, the whole all students take calculus thing. Tangent is what? Positive. Tangent, where else is, they're all positive in the first quadrant. Where else is tangent positive? Third quadrant, right? So you find the other quadrant where you're going to have an answer. It's going to be in the third quadrant. For tangent positive, if they gave you sine negative or something, there'd be different things. So for this one, tangent positive, third quadrant. Now, how do you do third quadrant? I gave you a rule in that YouTube video I sent you. I said if you're in the second quadrant, take pi minus whatever answer you got in the first case. If you're in the third quadrant, it's pi plus your answer. If you're in the fourth quadrant, it's 2 pi minus your answer. Did you see that? That's the YouTube video I sent you, and I explained how to find the second answer in the other quadrants. Now, why? Why am I doing that weird thing? I don't know if that made any sense. It's because, think about this for a minute. The first answer, remember I said change the first one to positive? What that does when you change it to positive is it puts it in the first quadrant. It puts it in the first quadrant because they're all positive in the first quadrant, right? So I'm saying the easiest way to do this is just to change your thing to positive. This one already was positive, but if they gave me negative, I would make it positive, hit the inverse tangent button on my calculator, get that answer, and say to myself, that answer is a first quadrant answer because it came from positive. All the functions are positive in the first quadrant. It's a first quadrant answer. So then, how do I find the other answer? Tangent, third quadrant. Well, think about the third quadrant. Remember, this is pi over 2. Well, who cares about that? This is pi right here, and this is 2 pi right here, right? This is pi, 180. This is 360, 2 pi, right? It's also 0, right? You good with that? So if your first quadrant answer, 1.11, is from there to there, that's what it is. That's the angle. It's the radian angle, 1.11. Instead of 70 degrees or whatever, it's 1.11. That's the radian angle. You with me? 1.11 is an angle. in radians. It looks, you think it's a number. It's an angle in radians, 1.11. It's the angle from 0 up to wherever our angle is. Well, I need to find the same thing in the third quadrant. What does that mean, same thing in the third quadrant? It means same from the x-axis. Remember, reference? Reference is from the x-axis. You catching all this? This makes sense? So from the x-axis, 1.11 added from the x-axis. So what is that? Pi plus 1.11. That's why third quadrant is pi plus whatever answer you got the first time. See why that's the case? If you were in the in the fourth quadrant, it would be back 1.11. So it'd be 2 pi minus the answer you got the first time. If you're in on you go. So I don't got time to explain everything. So let's get moving then. So what should I do then to find the other answer? I should take, since we are third quadrant, take my calculator and take pi plus the 1.11, the answer I got the first time. Right? That'll be the third quadrant answer. Pi plus, so use your calculator. Pi plus, that'll be 3.14. Plus 1.11 is 4.25. 4.25 is the other answer. There it is, D. We good there? So if you missed that YouTube I sent out, there's how you do the calculator one. That's that last thing I ran out of time on Monday, is how you do those. Is that good on that? All right, I'll move along. So, all right, I'm going to use my time well. So you look at all these and you're like, I don't know. So what should you do? Well, there's a lot of things you could do. I don't know.
That's just B, though.
Is it? Okay. So, secant. So you just got to start thinking about all the different properties. What is secant? 1 over cosine. Remember that? Secant. So this is 1 over cosine, and 1 over secant is cosine. So this is 1 over cosine minus cosine. Good so far? Sometimes, a lot of times, I just change everything to sines and cosines. So I changed secant to 1 over cosine, and 1 over secant is plain cosine. You good with that so far? Okay, now, how do you combine two fractions? How do you add or subtract two fractions together into one fraction? Common denominator, right? So I'm gonna multiply top and bottom of this one by cosine. Why? To make him have a cosine denominator like he does. Everybody tracking with me? So then this is 1 over cosine minus cosine squared over cosine. Good? Is this crazy? So what is that? 1 minus cosine squared over cosine. Good so far? I put them together into one. So what are my tips for doing these identities? Make everything sines and cosines. If they give you secant or tangent or cotan or cosecant, change them to sines and cosines. Just make everything sines and cosines. So I did that first off. And then I said, two fractions, common denominator. So, and now 1 minus cosine, and the minute you see 1 minus cosine squared, you need to know another identity. Or have it on your 3x5 card. Sine squared. Chanu's got it. Do you got it? You got it. It's just got to be like automatic. You got to know that so well. Remember, sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared. Those just have to reel off, be immediately recognized by you. So this top is sine squared, because it's 1 minus cosine squared. Remember those identities? Definitely have those. Right, that comes from the main one, sine squared plus cosine squared is 1. So if you subtract the cosine squared or sine squared to the other side, remember those? So, all right, so what does that mean then? Well, this is sine squared over cosine. Well, I still don't see it here, don't you?
You can split sine.
Good job, Wendy's got it. It's sine times sine over cosine. Sine over 1, yeah, split the sine. Sine squared is sine sine. Cosine is just 1 times cosine. Am I losing you here? Let me get a little more room here. Yeah, so this is sine squared over cosine, which is, split the sine like that. Sine times sine over cosine, good. And then what is sine over cosine?
Tangent.
Tangent. So that's sine times tangent, B, there it is. That was a hard one, wasn't it? So those are some of the fundamental things you need to do with identities. What? Change to sines and cosines. Let me just write that somewhere. Change to sine and cosine. That's always a very typical, useful, helpful step. Change to sine and cosine. Change to sine and cosine. So change to sine and cosine right away. And then common denominator, and then it comes together. All right, I'll move on. Okay, so sine squared plus sine squared cotan squared. All right, so what can you do with these guys right away? Factor out sine squared. Does everybody see that? They both have sine squared. When two terms have something matching, something the same, you want to factor it out. Do you know what I mean by factor it out? There'll be two things in here with a plus sign, and this times this will go back to this, and this times this will go back to this. Do you know what I mean? Remember factoring from your algebra days? So sine squared times what will go back to sine squared? Well, just 1. Sine squared times 1 is sine squared, huh? And sine squared times what goes back to sine squared cotan squared? Well, cotan squared. Good so far? Are we happy? Now what? I don't know. These are a little tricky. There is a formula. Yeah. So on your 3x5 card, you want to have 1 plus the tangent squared is the secant squared, and 1 plus the cotan squared is the cosine. These and also the sine squared plus cosine squared is 1. These are some of the ones you want to have in your 3x5 card. So these two you should have in your 3x5 card for sure. They're two of the fundamental identities we used in that section. 1 plus tan squared is secant squared. 1 plus cotan squared is cosecant squared. So when you see that 1 plus cotan squared, you think, oh, that's cosecant squared. Good so far? So what? Well, what's cosecant? This is 1 over sine squared. Remember, cosecant's upside down to sine? So cosecant squared's upside down to sine squared? This is over 1. What's this? Cancels? 1. That's 1. So that should be E, none of the above. Is that what it is? Yeah. That's all 1. That whole thing just became 1. It's a fancy way to write 1. You could do this and show, at social gatherings, you could impress your friends and show how that's just 1. That's what I do. I don't know why I don't have any friends. No, I'm just kidding. Is that good? Make sense? Everybody see that? It's 1. All right, let's go on to number 4. Okay, so I'm just going to abbreviate. Sine to the 4th minus cosine to the 4th. What's that? That needs to be factored. Do you remember factoring? We're hitting on a lot of algebra skills here. Sine squared minus cosine squared, sine squared plus cosine squared. Remember how to factor like that? Remember when you have something with negative powers like that, you can do that? Is that good? And then you want to have on your 3x5 card, sine squared plus cosine squared is 1, huh? So this is 1. So this is sine squared minus cosine squared times 1. So it's just sine squared minus cosine squared. But yet that answer is not there. And don't be too quick to grab none of the above. Good so far? I got probably one more step to take. Everybody good so far? So I factored this. This is factoring. Remember that from algebra days? A lot of yelling in that hall, huh? So sine squared minus cosine squared, sine squared. So whenever you have something, with powers with a minus, you can factor it this way. right? Those are half, right? Because if I FOIL that out, and I hope that's clear for you. If I was, let me prove this is true. This really equals that. If you were to FOIL that, if you were to go boom, boom, you would get s to the fourth plus s squared c squared, and then boom, boom, minus s squared c squared minus c to the fourth. These would drop out, so it'd be s to the fourth minus c to the fourth. I'm just proving that's true for you. All right, anyway, let's keep going. Where are we at? So now, what is this, and how does it look like any of those? Well, they have, it looks like, well, a couple of them have cosine, a couple of them have sine. Okay, well, remember, sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared. So, right? Remember, you got to know those again. So I could replace this sine squared right here with what? 1 minus cosine squared. And the other cosine squared is still there. Good. See what I did there? I replaced the front sine squared with 1 minus cosine squared. Why am I thinking to do that? Well, because they don't have a mix up there, do they? They have all cosine squared or all sine squared, not a mix. I've got sine and cosine. I got a mix. I got to replace somebody and get it all cosine or get it all sine, right? To see if my answer is the same as one of theirs. You with me? And so, what is minus cosine squared minus cosine squared? It's minus 2 cosine squared. There it is. That okay? Those hard? Yeah, you just got to practice. It just takes practice. It really is. That's how I always felt too when I watched my math teachers do them. I'm like, why didn't I see that? But it's practice. It's just practice. You got to get more and more familiar. So when you see sine squared, you 1 minus cosine squared, or just practice. These are the big 6. So these 3, and here the other 2 I just wrote up. 1 plus tan squared is secant squared, and 1 plus cotan squared is cosecant squared. Know those. And then, yeah, that's mainly it. But then we did some other tricks with common denominator. I mean, yeah, they're not easy. They're not easy. Yeah, Chunky.
Is it minus 2 because it's like 1 minus...
Right. It's just like because it's minus 1, like terms in algebra. Like minus 1x is minus 2x kind of thing from algebra. Yeah, minus 1 cosine squared minus 1 is minus 2. Exactly, it's just like terms, yeah. All right, we better move. Okay, so 1 minus sine squared over 1 plus cosine. Yeah, what's that? Okay, well, as soon as how's your recognition going? As soon as I see sine squared, what can I do? 1 minus cosine. And why would I want to, not that you always replace sine squared with 1 minus cosine squared. You always know you could. Why? And in fact, here I should. Why? Because the bottom has a bunch of cosine. So I'm thinking, I can make the top a bunch of cosine also, and then probably something good will happen. It will. Let's see it. Sine squared is 1 minus cosine squared. Good so far. Whoops, thought I changed the thing. Come on. Okay, so we get to there. And then now, what in the world? Okay, so what now? Well, as soon as you see 1 minus cosine squared, you have to remember from algebra. How can I factor that?
1 plus cosine, 1 minus cosine.
Yeah. So that just needs to be right there. That's the same thing I did over here a minute ago when I had this one. And I said, whenever you have powers, subtract. It's called difference of squares factoring. Remember that from algebra? If not, you need to brush up. You need to think on these 2 examples and bring that back to the front of your mind. You need to know that, especially going into pre-calculus. You will not survive if you're not clear on that. You got to know algebra. So so whenever you have 2 things subtracted, you can factor with 1 minus, 1 plus in the middle, where the powers are half of the original. Right? That's difference of squares factoring. Same thing here. See if I multiply this out, 1 times 1, 1 times c, then boom, boom, plus c, minus c squared. These would cancel, go back to 1 minus c squared, wouldn't it? See how that's right? Remember that from algebra? Now why? Why do I care? Well, because you see how it's going to cancel the 1 on the bottom, the 1 plus c will cancel. See that? That's why I was going there. From the beginning, I saw that. I just thought, oh, sine squared is 1 minus cosine squared. I can factor it, and the 1 plus c's will cancel. The more you do these, you'll see that coming. You go, oh, they want me to factor, cancel, and because when you see that 1 plus c in the bottom, you're thinking, oh, this, and it'll have the 1 plus c, and it'll cancel. Okay, now what? Well, that's 1 minus c. Good so far? And then what do you do with a minus in front of a parenthesis? Distributes 1 minus 1 plus c, which is just c. It's just cosine. Good. This takes a lot of practice. So these dropped off, this came down, distributed the negative to both. My negative changed both signs, made it a minus 1 and a plus c. 1 minus 1 is 0, so it's just gone. It's just cosine. It's just cosine. All right, let's move on to number 6. Okay, so cosecant squared times secant. Now, what did I suggest? What should you do first on this one? Sines and cosines. Good, Ajane. Yeah, make it sines and cosines, right? When they give you weird functions, cosecant, secant, cotan, just make it sines and cosines. So, all right, so cosecant squared, what is that in terms of sines or cosines? 1 over sine squared. No, I don't want to go to that. Or maybe I do. And maybe I do, Chinu. You're making me think. Maybe I do, huh?
Yeah, I got stuck on that one too. I wasn't sure.
1 plus the 1 plus cotan squared. And would that be nice then? I don't know. Yeah, you might be right. Yeah. There's a couple of things. Yeah, Chinu has some wise words. I better listen to him. Yeah. I mean, what I'm saying is true in the sense that cosecant, secant, a lot of times you go to sine and cosine. Yeah, but look at all the answers over here. None of them are sine and cosine. So they stayed in the secant, cotan, whatever world, didn't they? So I probably should too. Right? So yeah, I'm going to do it. So I'm going to think, okay, yeah, I don't really want to go to sines and cosines because the answer is not in sines and cosines. They didn't go there. I'm trying to match up one of those. So, okay, so what else can I do? Yeah, what Chinu's saying. Remember 1 plus tan squared is secant squared. You have that in your 3 by 5 card. And 1 plus cotan squared is cosecant squared. So I can replace cosecant squared with 1 plus cotan squared. So this becomes 1 plus cotan squared. Everybody good to there? Right? Cosecant squared is 1 plus cotan squared. Good so far. Now, I'm looking at these answers. See how they've distributed them? So I'm going to distribute. I'm just trying to imitate the answer and to match up. So secant times 1 is just secant. And then this is cotan squared times secant. I'm going to skip the x's if that's okay. Cotan squared times secant. See what I did there? I just multiplied the secant, distributed it to both those. Secant times 1 is just secant. And secant times cotan squared. Now, it doesn't yet look, it kind of looks like B almost, not quite. What could I do? It's probably B. I don't know.
The answer is B.
Yeah. Here's what you could do. Now, because this is kind of weird looking, right? You could look at that and you could say, well, there's a couple things you could do. I'm going to make it cosines and sines now. What's cotan squared? Cosine squared over sine squared. And what's secant? 1 over cosine. You guys with me? Are you tired of these? You see that? You see what I just did there? Remember, because cotan, right? Tan is sine over cosine, so cotan is cosine over sine, upside down, right? Remember that? So cotan squared is cosine squared over sine squared. Right? And secant is 1 over cosine. So what? Well, now cosine Goes into one of those and leaves that first power. Okay, so what? Well, that leaves me with cosine over sine squared. Right? Across canceled there. Cosine over sine squared. We're almost there, guys. I promise. We're one step away. Do you see it now? What did we do last time we had something like this a minute ago? This is cosine over sine times 1 over sine. Remember, you separate the signs, right? Sine squared, you make it 2 sine, and then what? Right? It's cosine over sine with another sine, right? Like we did this a minute ago on another problem. We okay with that? And what's cosine over sine? Cotan and 1 over sine. Cosecant. It's cotan, cosecant. Cotan, cosecant with a secant in the front. Yeah, it is B. See how it's the same as B? So that takes hours of your life. It does. It does. Really, more and more and more, I always want to help. 20 years of teaching. I want to help. I think one of the big problems for math students who want to go into the world of math and science is realizing this will take your life. So if you don't want to give it your life, do something else. Really, really, be wise. What would not be wise is to be half in. It won't happen. You'll fail. If you're half in and just try a little bit, do an hour of homework a week, go do something else. You're just wasting 4 hours of your life every week coming to this class. And really, I'm not trying to be discouraging. This is how I would talk to my own children. I would say, if you want to do math science, you got to give it your life. This didn't come to me because I every now and then did trigonometry. It was my life during those years. I just night and day, I did math. I did. So that's what it takes. So all this, I'm going to move on now, but I want you to know this doesn't come to the casual. So if you really want to go the math science road, trig, pre-calc, calc, you have to do this like 15 hours a week. You do. That's what it takes. That's just the reality. I say that for your own good, right? So you can make a wise decision. You're thinking, well, I don't want to get. Well, then don't do this. This isn't going to work. Do some other major that's not math science. Math science. My own daughter right now is. One of my daughters went the animal science, and it's a little easier for her. Her little animal classes aren't too demanding. And then my other daughter wants to do the math science thing. I'm like, okay, honey. And then she's taking chemistry and calculus right now. And she's like, it's so much work. I'm in that chemistry lab all day long. And I'm like, yep, that's the math science road. And I'm like, you don't have to do this. Do something like your sister did something else. But no, I'm real clear with her. No, this is what it means. It takes your life. It takes hours and hours and hours. This doesn't come to the couch. So if you want to learn this, you got to go back to that homework. You got to go back to that homework and redo those problems and do these a bunch of times. All right, we got to move on. We've been all alone. Those ones are harder than I thought. These are hard. I'm with you, thinking this is a tough test. There's a lot of hard stuff on here. So boom and a boom. It says find the exact value. What does that look like right there?
Cosine A plus B.
Yeah, that's the cosine formula, huh? So you want to have that on your paper? Cosine A minus B. That's cosine, sine. So it's A, B. Have that in your test. And remember, cosine's not your friend, like my buddy memorized it that way. Minus becomes plus. Remember that? Like that. So cosine A minus B is cosine, sine. Like that. So that's what they've done, huh? They have the cosine of two angles subtracted. All of this is the result of the cosine of two angles subtracted. What are those two angles? 165 and 45. But notice they're subtracted. How do I know? Because they're adding here in the middle. Everybody see that? Cosine does opposite, right? Do you have that formula on your 3x5 card, or will on Monday? So minus in cosine means plus in the middle. So this plus here must have come from minus. So it's 165 minus 45, 120. So that's cos of 120. That's cos of 120, isn't it? Everybody good with that? So what's the cos of 120? Can we do the cos of 120? Here's 90. No, here's 90. And so 120, unit circle. Are you okay with the unit circle? There's 120. 30 degrees off of the 90. All right, so what is cosine of 120? Let me help this way. Cosine of 120 degrees. Let me help because you got to have the unit circle. Yeah, we have 20 minutes left. You've got to be able to do the unit circle, or you just won't get any. You'll fail. If you can't do the unit circle, you will fail the exam on Monday. If you can't take that unit circle without a calculator and find what the cosine is there, I mean, do it so that you're right 95% of the time. I don't mean, every now and then I get one right. You've got to be solid as a rock on getting these. So let me help you. If you're not, come see me. Like I said, somebody came just yesterday. That was wise of that person, and they're solid now. Come see me. Come see Roberto. That's what I had to do. Like I said, it was my life. I made sure I knew every single thing, and I went for help when I did not until I knew it. It was my life. So you got to make sure you know this. So how do you do? So let me offer whatever help I can generally. So cosine, when you see cosine, is that x or y? X. Everybody, if you don't know that, nothing good's going to happen. You got to know cosine is sideways, sine is up and down, right? So let me say this. And this angle here, this is back. Isn't that back? That point right there, he is back a little bit, and he's up a lot. He's back a small amount. He's up a large amount, isn't he? To that point right there. So that's back a half, and that's up root 3 over 2. It's back a half, up root 3 over 2. So what's the cosine? The x. Back a half. Cosine is the x. Cosine is the right-left, in other words, isn't it? Cosine is right-left. Sine is up-down. You with me? Sine is always up-down. Cosine is always right-left. What's this one? This point, he's left a small amount. He's negative left a half. Remember the small, medium, large. Half, root 2 over 2, root 3 over 2. Small, medium, large. He's the half. But he's left half, so negative a half. D. Good there? I'm going to move on. So there's the sine formula. Sine, cosine, sine. That's the sine formula. That's the sine of the two angles subtracted. Why? Because it's minus in the middle and sine stays with the same. Cosine does the opposite sign. Sine formula does the same negative or positive in the middle, doesn't it? Are you clear on that? So when we see negative on sine, we know it's negative in the formula. Whereas the last one, we saw positive in cosine, we knew it led to negative in between. Cosine switches. Okay, so this is sine of 240. So let's go to 240 degrees. This is 180. This is 270. Where's 240? 240 is right there, just 30 off of 270. So tell me about that point right there. I'm doing sine now. So what am I thinking about? Right, left, or up, down? Up, down. Remember, sine is up, down. Cosine is right, left. So I'm asking, is that point up or down? I'm not thinking about right, left. I'm doing sine. Sine's up, down. Cosine's right, left. So I'm saying, hey, point, you 240 degree point, are you up or down? Well, clearly down. And how much is he down? He's back a little, down a lot. He's down a large amount, isn't he? So he's down root 3 over 2, the large value. Good? Can you do that without a calculator like that? All right, get the help you need. I'd be glad to help. All right, next one. Cos 285. So I'm going to... Okay, so 285. How do we do it? Well, give me a hint here. Rewrite this as two angles added or subtracted, then solve. What I mean is 285 is not one of our memorized values. We don't know 285 unless you use a calculator. We can't do it without a calculator. Right, but make it two things we do know. What two numbers can add up to be 285? That are ones we know, I mean. You might say, well, how about 285? Problem is I don't know 200. 200 is, if I put 200 on the unit circle, where's 200? Here's 180. It's like 20 degrees off of 180. I can't do that. Remember, we can only do 30 degrees off of the main plane. We only memorize the 30 degrees off, or the 45, but not 20. I don't know 200. I have no idea. So I don't want 200. What two numbers could I do? 240 and 45. Those are both memorized values, aren't they? There might be another pair. I couldn't think of another pair. But
245 and 60.
oh, nice. 225 and 60. That'll work too. Yeah, pick any two that are memorized values that add up to be 285, and that's great. So yeah, so those two I do. Did everybody see why I'm picking those? Because 240 and 45 are memorized spots. All right, so what does that mean then? This is that the cosine of 285 is the cosine of 240 plus 45. And what's the cosine of a plus b formula? Cosine, cosine, sine, sine. So you just, and he's not our friend. So he has opposite sign. Plus here becomes minus in the middle. 240, 45, 240, 45. Good to there? Then go to the unit circle. Put it on there. Find the two words 240. Right here is 240. We just did 240 a minute ago, huh? 270 is there. So what about 240? Let's do the cosine of 240. Cosine is what? Up, down, or right, left? Right, left, huh? Cosine's about right, left. So cosine of 240 is right, left. So this point is clearly left. It's left a small amount, left a half, isn't it? Good so far. And now let me do this one. Let me just do both the, and bring that minus down. That's subtraction in the middle right there. Bring that down. And in this, now sine of 240. Sine is up, down. So this point right here at 240, same dot, but now I'm thinking about it's up, down because I'm doing the sine of 240. That's down a large amount, isn't it? Down root 3 over 2. Is that good? See, 240 is back cosine, small amount, down sine, a large amount. Now, how about the 45? Let's do the 45. 45 is right here. That one is over and up, medium, right? That's in the middle. Root 2, root 2, root 2, root 2, both sine and cosine. Root 2 over 2, root 2 over 2. For both sine and cosine, same thing. Over and up, same amount. Medium, medium. Good? On that, now, multiply these together. 1 times root 2 would be negative root 2. 2 times 2 is 4. Minus and minus, plus. Root 3 times root 2, root 6. 2 times 2, 4. Good to there. Now, is that the same as any of these answers? Yeah, they've written, for whatever reason, I don't know why the publisher's multiple choice answer bank wrote the answers out like that, but you know algebra, right? You can test them. Just come on up here and take that first answer. Well, I'll just take the correct one. See D here, which is root 2 times root 3 minus 1 over 2, or over 4, I mean. If you were to take this, go boom, boom. What's root 2, root 3? Root 6 minus root 2 times 1, root 2 over 4. That's the same as this. See, the root 6 is positive, the root 2 is negative. They're both over 4. It's D. See how that's the same? If you just distribute, they just had theirs factored for some reason. It's not required. I just took D and I just distributed it, right? I just took this root 2 times root 3 is root 6, and root 2 times 1 is root 2. I'm just proving D is the same as our answer. Is that okay? Did y'all see that? Questions on that one?
Yeah.
Yeah. Maybe I'll move one of those to the calculator part, because these are kind of hard by hand. I don't want to use up too much of your time. Okay, so let's give it a try. Quadrant 3. So I'll go to quadrant 3 over here. Put the angle, alpha, or you can just call it theta, whatever you want. The cosine is 4/5. Remember the SOHCAHTOA. SOHCAHTOA. Cosine is adjacent over hypotenuse, right? So cosine is adjacent over, so it's adjacent over hypotenuse. So it's 4/5. So this is the angle. This is the adjacent. This is the hypotenuse. This is the opposite. So cosine is minus 4/5. Like that. Everybody good with that right there? Right, because cosine is adjacent over hypotenuse. right? What does this other side have to be? Yeah, remember the 3, 4, 5 triangle? It'd be good to put right on your sheet 5, 12, 13. That's a very common Pythagorean triple. 3, 4, 5. And then I noticed another one. What is it? 5, 24, 25. Is that what it is? That one we were working on?
5, 12, 13, I think.
Oh, is it? Oh, yeah, I got 5, 12, 13. But isn't there like
Oh, yeah.
5, 24, 25? Is that true? Let me just check it real quick. Is that one right? 24 squared plus 25. No, that's not right.
Might be 17, 21 or something.
What is it?
Oh, yeah.
7, 24, 5? Is that what it is? Yeah, it's just good to have those because they come up. Is that what it is? Oh, yeah, you're right. I remember it now. Is that, and yep. Good job. That's it. So put those three right on your 3x5 card. Those are commonly used. Anyway, let's get back to this problem. So they want the, and they're telling me the sine of, oh, and they're giving me B, another angle. I got to do both of them. This is a painful problem. All right, so I got to do another one. So let's do that. So I got to go over here now and go into quadrant 2 and make angle beta. And the sine of beta is root 21 over 5, right? Sine is opposite over hypotenuse. And here's the adjacent. So, okay, so for that one, I'm going to have to find the missing side, aren't I? So I'll do that one. A squared plus B squared is to the Pythagorean. So I don't know what this is. Call this x or whatever. X squared plus root 21 squared is 5 squared. So x squared plus 21. Right? The root and the square cancel each other out here. And this is 25. Subtract 21. X squared is 4. Root it. X is 2, isn't it? X is 2. So this is 2 right here.
Mr. Herring,
Yeah.
it's supposed to be in quadrant 2, not quadrant 1, so that would be -2, right?
Oh, yeah, thanks. I'm putting in quadrant 1. Thank you. Let's fix that. Quadrant 2. Beta right there. So what was my thing? It was sine of beta is root 21, opposite over hypotenuse 5, and that is back 2, right, back 2. On that, thank you, Luke. There we go to there. So now we're ready, I think, to finish this thing up. So let me go up here and, oops, I probably shouldn't erase that. So I need all this stuff. What was this one? 4? That's 4. All right, so now finally, what do they want me to do after all this? They want the cosine of alpha plus beta. So now after all that painful work, you've got, this is going to be time intensive, even though there's only 20 questions. It takes a long time. Cosine alpha plus beta, what is it? Cosine, sine, right? Alpha, beta, and cosine's not our friend, minus in the middle. Okay, so here we go. What's the cosine of alpha? Well, that's just minus 4/5. They just gave me that. What's the cosine of beta? Here's the beta triangle. What's the cosine? This is opposite, adjacent, hypotenuse. It's adjacent over hypotenuse. Minus 2/5. Now, for the sines, if you have any trouble with the sines, remember the all students take calculus. You could always do that. You know cosine's negative in that quadrant. Bring down the minus. Now, what's the sine of alpha? Go to the alpha triangle here. What's the sine? Opposite over hypotenuse, 3/5. No, see, I'm messing up, huh? Should be negative. Remember the all students take calculus? Here, I'm running out of colors and things here. All students take calculus. So in the third quadrant, only tangent's positive. Sine is negative 3/5. So watch this, because this is really a negative 3. But you don't have to put them on the triangle. You can just keep using the all students take calculus. You with me? Make sure you get the right signs on that. Finally, sine of beta. They gave me that straight, didn't they? Sine of beta is right there. Root 21 over 5. Whew, this is a difficult problem. All right, so we're almost done. So What do we got now? So negative times negative is positive. 2 times 4 is 8 25ths. Negative and negative is positive. What is that? 3 root 21 over 25. Hopefully that answer's there.
Yeah, that's
Oh, good. There it is. Hours of your life, if you want to learn that. It's a great pay. I mean, to say you get a math science degree, you have no trouble getting a job. No trouble. I can tell you tons of people I run into with history degrees. And I love history. I love it, but nevertheless, history, philosophy, and they're doing jobs they hate because employers know the difference. They do. So anyway, so I'm beating down math science, but it does pay. You put in all that work, you get a job, no problem. No problem. I had offers from Cal. I wanted to teach. I couldn't get teaching right away. So I thought, all right, I'll try something else, At Cal Poly, people would come all the time, companies. So I just showed up at some random, I just kind of picked a company at random. They would come to our school and interview people. I just sat down and interviewed with a guy for an hour or something like that. And he invited me out to his company in LA. They estimated things. Isn't that weird? Their whole job was estimating. My wife and I went out and visited them in LA and met a bunch of them and talked to them for 3 hours at their site. And their whole job was estimating. They had like 10 math science people that just sat in these offices, and like if a government was going to build a big satellite or a big whatever, or some city council was going to build a gigantic park or something like that, and they wanted to know how much it was going to cost, they would hire this company to estimate the cost. It was a bunch of math science people who were good with numbers, and they would just sit around and they would produce an estimate of exactly what it'll cost, and they give it to the board of directors, whoever, so they can make an informed decision about whether they really want to do that project. That was it. That's all they did, was estimate things. It seemed boring to me, so I did not take the job. But my point is, it was easy. I could have had a job. Now, he didn't know me from Adam, but he knew I had a math degree from Cal Poly, and he was ready to offer me big dollars, big job, just like that. So it's a snap if you get a math science degree, but it's a ton of work to get one. Any kind of degree in science or math, as you know. It's kind of funny, my wife was sitting in the lobby, and I went back and interviewed for 3 hours, back with the different people. They're very nice. I came out, and my wife and I were driving home, and my wife said, I was in the lobby waiting for you, and 2 of the employees came out to talk to the secretary, and they said to the secretary, yeah, we spent the night in our offices again last night, slept on the sleeping bags. That's how hard their projects were. They're working all night. And as soon as they said that, the secretary looked up over at my wife and said, well, they don't usually do that. Yeah, sure, right. My wife told me that on the way home. I'm like, no thank you. I called him back. No thanks. I think I'm going to try teaching. So number 15, cosine 3 pi over 8. So, all right, let's take 3 pi over 8 and change it. Make that 180 over 8. So this is by hand work, isn't it? That's a pain. So I guess I got to do it by hand. 3 times 180, 0, 24, 540. And then I can divide that by 8. 8, I don't remember. 7, 6. 6 times 8 is 48. What does that leave? 60. Wait, I'm not reducing this thing very well. Here, let me go back. Let me not do it that way.
180 goes into 8. 10 times.
So it's 540 over 8, and then I got to reduce that thing. You're saying it goes in?
180 goes into 8. 10 times. 10 times 3 is 30.
180 doesn't go into 8 10 times.
180.
All right, so 540 over 8. Let's reduce that thing. So I'm just going to do what I was doing. That was right what I was doing. So 6 times 8 is 48. 60. 7 times 8 is 56. 4. You remember all this? We get to here, we got a 4. 4 eighths. Remember that? Which is half. So that's 67.5. Or maybe I'm probably confusing you. Add a 0.0, bring down the 0, 0.5. 67.5. That good? Been a while since you've done that by hand work? 67.5 degrees. So they're asking me about 67.5 degrees. I don't know that one. That's not one of my memorized values, is it? So how do I do 67.5 degrees? Yeah, that's what they're saying. Replace it with double that. So what's 67.5 doubled. 100, and if you do it by hand, you'll find it's 135 degrees. So in other words, they're saying you could use the formula for cosine of a half times 135 degrees, because that is the cosine of 67.5. Does that make sense? The cosine of 67.5 is the cosine of a half times 135. It is. Is that good so far? So therefore, so this equals this. So then I use the half angle formula. What's that? Isn't it plus or minus the square root of 1 minus the cosine, or plus? Is it plus? I think it's plus. You have it on your 3x5 card. Over 2 like that. Isn't that what it is? Isn't it plus?
That's plus.
Plus. You get like that. Okay. Now, what are we going to do with that? Well, now we can figure it out because we can find the cosine of 135. Right? 135 is a value we can handle on the unit circle. So again, it's all about the unit circle. So let's go to the unit circle, find the cosine of 135. So let's do that. So go to the unit. Where's 135? Well, here's not 180. Here's 90. So it's halfway right there. 135 is right in the middle. It's add 45 from 90, huh? 135 is right there. What's the cosine? Well, it's medium, medium. Root 2 over 2, root 2 over 2. Is it positive or negative? All students take calculus. Only sine is positive in the second quadrant, so cosine is negative. So this is plus or minus the square root of 1 minus root 2 over 2 all over 2. You all with me to that point? Cosine is minus root 2 over 2 for 135. All right? Oh, and by the way, what's the sign in the front? That's 67.5. Remember, the front is the original question. Right? It's not the 135. The 135 is this little part in here. But the original question that we're answering is, what is the cosine of 67.5? That's what 3 pi over 8 is. Right? That's what we're really trying to answer. What's cosine of 3 pi over 8? What's cosine of 67.5? That's in the first quadrant, 67.5, where they're all positive. So that's positive. So right away, forget that negative answer and forget that negative answer. No way. Right? Just by that alone. Right? So now, so how do you finish that up? We finish with this. 1 minus root 2 over 2 over 2. How do you clean that up? Remember what you do? Multiply by 2, everybody. We did a couple of these. It cancels here. And you get 2 minus root 2 over 4. And what's that root 4 on the bottom? Root 4? That's a half. It's that. It's B. Everybody see that? The square root of 4 on the bottom is just that 2 right there, out front. See why it's a half? Because the 4 is on the bottom. Square root of 4 is 2.
Now you skip this one. That's okay, I'll see you at office.
Is that confusing? Everybody, did I confuse you guys with that last maneuver? Right? It's just a 4 in the bottom. It's in a square root. So you can take that square root, let me do one more thing, that square root that's over the whole fraction, and you can put it on the top and on the bottom. You can always just separate it. And what is the square root of 4 on the bottom? It's a 2. Right? And then 2 on the bottom is the same thing as a half in the front, isn't it? Makes sense? Right? So a square root over an entire fraction, you can make root top, root bottom. Root of 4 is just 2. That's the same thing as a half in the front. All right, this is hard material. How about we do this? I want to put the exam off one meeting. I'm a little nervous about how hard this material is and how ready you all are. I don't want you to all tank. I have to hold these standards. This is the standards. The state of Cal. I didn't make this up. State of California says this is what you'll learn. They give me a sheet of things you will learn, and these are all on it. So I can't move the standard, but I can do everything I can to help you meet that standard. So how about we put the test on Wednesday? Let me put it back. I'm going to move ahead with new stuff, though. I got to keep the train moving, or we'll run out of time on other hard stuff. But this is our hardest test, I think. Let me move it back to Wednesday. Give you a week. I encourage you to really pour over this weekend. Make it your life if you want to go this road. Have a good weekend, guys. Come see me. Be glad to help you today, 12 to 1.